In the dark between stars, a ship 36 miles long is falling toward Proxima Centauri. Inside, a child is born who will never see Earth. She will die before arrival. So will her grandchildren. We are going aboard. You will watch the air thin, the bones melt, the genes narrow, the crew forget why they left. If this journey grips you, like and subscribe, and ride with us. Seal the doors behind you. We begin. A ship leaves Earth at 40,000 miles an hour, and it is still hopelessly slow. That is roughly the speed of Voyager 1, the fastest object humans have ever thrown out of the solar system. It launched in the 1970s. It passed Jupiter. It passed Saturn. It crossed the boundary where the sun's wind finally gives up. Point that same craft at the nearest star system, and it would arrive in about 75,000 years. 75,000 years ago, our ancestors were still learning to paint on cave walls. The first problem with a generation ship is a number, and the number is merciless. Proxima Centauri sits 4 light years and 3 months from here. Light crosses that gap in 4 years and 3 months, and light is the fastest thing that exists. Written out in miles, the distance runs to about 25 trillion. Nobody can picture 25 trillion, so shrink the whole thing. Take the distance from Earth to the Sun, 93 million miles, and squeeze it down to 1 inch. Hold that inch between 2 fingers. On that scale, the entire orbit of Neptune fits neatly on a dinner plate. Every planet, every moon, every place a human being has ever set foot, all sitting on 1 plate, and the nearest star, over 4 miles away. A dinner plate, then 4 miles of absolutely nothing. That is the wall. The only honest way through it involves fusing hydrogen behind you and riding the blast. Engineers keep circling back to fusion because chemical rockets are finished before they start. Burn fuel the way rockets burn it today, and the trip stretches past 100,000 years. Fusion squeezes hydrogen until it collapses into helium, the same reaction that keeps the sun lit and throws the exhaust out the back. The winning design in a recent worldwide competition does exactly that. A ship called Chrysalis burns helium-3 and heavy hydrogen, and it accelerates at about 1/10 of Earth's gravity. That is a gentle shove, a feather-light press in the small of your back, but it never stops. That is the trick. A small push, held for year after year, builds into a speed that would cross the United States in a blink. 400 years to Proxima. Say the number slowly, because the number is the whole story. 400 years ago, no human had ever seen a bacterium. Nobody knew what oxygen was. Nobody had heard the word galaxy. Now imagine handing those people a machine and asking them to keep it running, flawlessly, until today. Everyone who walks up that boarding ramp will die inside those walls. Their children will die inside those walls. Their grandchildren, their great-grandchildren, and 6 more generations after that. The only humans who ever stand on the New World will be strangers to everyone who built the ship. That is the offer. You give up the sky for 10 generations, and you never meet the reward. The strangest part is that crossing the distance is the easy half. Keeping 10 generations breathing across 400 years takes something far bigger than a spacecraft. It takes a country sealed in metal, with its own farms, its own weather, and its own dead. The winning blueprint runs 36 miles from nose to tail. Its weight is the part that stops people cold. The nose of the ship is the smallest part of it, and that is deliberate. Picture a cocoon, a long metal cylinder tapering to a narrow point at the front, with the living rings stacked behind it like slices of a loaf. The point stays thin because the point is the target. Everything the ship meets at cruising speed meets that tip first, and the less of it there is, the less there is to destroy. Behind the tip, the numbers turn absurd. The Chrysalis design measures 36 miles from front to back. Manhattan is 13 miles long, so this thing is nearly 3 Manhattans laid end to end, flying through the dark. Its widest section spans almost 4 miles across, which means a person standing inside it and looking up would see farmland curving overhead, like a ceiling made of fields. And the mass, 2.4 billion tons, roughly 400 Great Pyramids, every one of them pushed up to speed and slowed down again. That figure sounds like a design that got out of hand, and it comes from arithmetic no engineer can argue with. Every problem on a 400-year voyage has the same answer, and the answer is mass. Start with food. A team studying multi-generational crews worked out how much farmland it takes to feed 500 people forever, with zero resupply, using only what grows on board since dried rations rot long before the halfway point. Their answer landed near 110 acres, about 80 American football fields of crops, growing under lamps, tended by people who will never taste anything grown in soil that a wild insect has touched. Now stack the rest on top: water and the machines that clean it, air and the machines that scrub it, soil, which weighs more than almost anything else on board, a hospital, a school, a workshop, metal to rebuild the workshop when the workshop wears out, metal to rebuild that metal. Then comes the shielding, and shielding is where the weight becomes monstrous. Out there, invisible particles pour through everything. The only cure anyone trusts is bulk, rock, water, waste, packed thick around the places where people sleep. Every inch of that armour is dead weight that the engines must drag across 25 trillion miles, and every inch of it is the reason anyone survives to see the far side. Third place in that same competition went to a team who gave up on building a shield at all. They hollowed out an asteroid and flew inside it. Let the rock take the beating. There is a reason the winning team called their ship a cocoon rather than a vessel. A vessel carries you. A cocoon keeps something alive while it changes into something else. Inside, they sketched a chamber called the Cosmodome, a wide window where people could float and look out at the stars, a luxury on paper. In practice, it may be the single most important room on the ship, because 10 generations of humans have to look at something other than a wall or they will come apart. We will get to what happens to those minds. First, the bodies. Because a ship this heavy has one more problem, and it is the problem that shapes everything else. Out there, weight vanishes. Bodies float, bones dissolve, muscles waste. A baby born in free fall may never learn to stand at all. So the engineers made a decision that sounds insane and turns out to be the only option available. They decided to spin the whole thing, drop a wrench on this ship, and it lands 3 inches to the left of where you aimed. That is the price of the trick that keeps everyone alive, and the trick is old. Take the whole cylinder and spin it, slowly, around its long axis. Stand on the inside of the outer wall. The wall pushes up against your feet to keep you moving in a circle, and your body reads that push as weight. Swing a bucket of water over your head fast enough and the water stays in the bucket. Same idea. The ship is the bucket. You are the water. It works perfectly. It also breaks your inner ear. The problem is size. Spin a small ring, and you have to spin it fast to make the push feel like Earth. Spin it fast, and every time you turn your head, the fluid in your inner ear gets dragged sideways by the rotation. Your ear reports one motion, your eyes report another. Your stomach picks a side and your stomach loses. Engineers found the ceiling decades ago. Turn the habitat more than about 2 rotations per minute, and healthy adults start throwing up. Which sets a hard flaw on the design, because to feel like Earth at that lazy speed, the ring has to be enormous. Roughly 700 feet from the centre out to the floor, taller than most skyscrapers, standing on its side, turning like a slow record. That is why a generation ship has to be gigantic. The nausea sets the diameter sets the mass, and the mass sets everything else. And the strangeness does not stop at your stomach. Inside a spinning world, physics develops a personality. Walk in the direction of the spin, and you get slightly heavier. Turn around and walk the other way, and you get lighter. Sprint hard against the rotation, and your feet start to leave the floor. Pour water from a jug, and the stream bends. Throw a ball, and it curves like a slider. Climb a ladder toward the centre, and your weight drains away with every rung until you float at the middle, watching the world you left turning below your boots. Children raised in there would find our physics broken. Water that falls straight down, balls that fly true. To them, Earth would be the weird place. Then comes the part that nearly killed the idea. Spin something that massive, and it becomes a gyroscope. Try to steer, and the ship fights back, twisting in a direction nobody asked for. Billions of tons of angry momentum, resisting every course correction for 4 centuries. The winning team solved it by cheating. They built the habitat in stacked rings and spun them in opposite directions. Odd rings turn clockwise, Even rings turn counterclockwise. The two forces cancel, and the ship steers like an ordinary vessel, while the people inside stay pinned to their floors. The runner-up team hung 2 rings on either side of a central spine, each 500 meters across, spinning against each other. So the gravity problem is solved. On paper. Here is what the paper does not tell you. Nobody knows how much spin gravity a human being actually needs. We have data at Earth's pull. We have data at 0. Between those 2 points sits a blank, and inside that blank live 10 generations of children. To understand the size of that gamble, look at what happens to astronauts who spend 1 single year floating. Their skeletons start disappearing. Astronauts come home from the space station and for a while they're afraid to fall. 6 months of floating does something to a skeleton that nobody expected the first time they measured it. Bone drains away at roughly 1% every month, concentrated in the hips and the lower spine, exactly the places that hold a standing human upright. Compare that to aging. An elderly person on Earth loses bone at about 1% per year. So, half a year in orbit cost a body what 6 years of getting old would cost it. Some crews come back with skeletons that have aged a decade while their faces age 6 months. The reason is a thing your bones do every day, and you have never once noticed it. Think of your skeleton as a construction site that never closes. One crew tears old bone down. Another crew builds new bone up. The two work in balance, and the foreman shouting orders is gravity itself. Every step you take sends a small shock up through the bone, and that shock is the signal to build. Take gravity away and the shouting stops. The demolition crew keeps working. The builders go home. Calcium leaves the bones and enters the blood. The blood dumps it into the kidneys, and now the crew has a second problem because kidney stones in a place with no hospital and no ambulance is a nightmare that keeps flight surgeons awake. So astronauts fight back with machines. More than 2 hours a day, every day, strapped into resistance rigs, hauling against pistons that fake the weight of a barbell. It is a full-time job on top of a full-time job, and it works only partially. Follow those astronauts a year after landing and the story gets grim. Many of them still have not rebuilt what they lost. Bone that vanished in 6 months does not always come back in 12. Some of it appears to be gone for good. 6 months. Now stretch that to 400 years. This is precisely why the engineers spin the ship. Spin restores the shouting, spin puts the foreman back on site. If the floor pushes up on your feet, the shock travels up your leg, the builders return, and your skeleton behaves like a skeleton. But look closer at the blueprint and a crack opens up. Only some decks on that ship get full Earth gravity. The closer you climb toward the centre, the lighter you become. The observation dome floats near the axis, because that is where the view is and where people go to play. The workshops, the storage, the hub where the rings meet, all of it sits in a zone where your body weighs a fraction of what it should, which means the children of that ship will grow up commuting between weights, heavy on the farm deck, light at school, weightless at play, and here is the hole in the plan. Human beings have been measured at Earth's gravity. Human beings have been measured floating at 0. Between those two numbers lies a gap that no experiment has ever filled, apart from a handful of men who walked on the moon for 3 days each. Nobody on this planet can tell you what 1/3 of a gravity does to a growing child over 18 years. Nobody has the data. The whole design rests on a guess. And bones are the easy part, because the same missing gravity does something to the eyeball that nobody saw coming, and it is stealing astronauts' vision right now. There is a drawer on the space station full of glasses in different strengths, and the crew calls them anticipation glasses. They are there because astronauts arrive with perfect vision and slowly stop being able to read. Something out there reaches into the human eye and changes its shape. Roughly 7 out of 10 people who fly long missions show some sign of it. Doctors gave it a name only recently. Once they accepted it was happening to almost everyone. The cause starts in the legs. Your body is a plumbing system tuned by 4 billion years of falling. Blood wants to pool in your feet, so your heart and your veins spend all day pushing it back uphill. Take the hill away, and roughly half a gallon of fluid that normally sits in your lower body goes wandering upward and settles in your skull. Crews call the look puffy face bird legs. Their heads swell, their calves shrink, their faces round out like they've been crying. That fluid has to go somewhere, and the somewhere is behind the eye. Pressure builds in the skull and presses on the back of the eyeball. The eyeball, which is basically a soft ball of jelly, flattens slightly at the rear. Flatten the back of a camera and you move the film. Now the lens focuses in the wrong place, and distance turns to fog. The optic nerve swells where it enters the eye. Fine wrinkles appear across the tissue at the back, like creases in fabric that has been squeezed. Then the scans came back from the brain, and they were worse. The brain itself drifts upward inside the skull. The hollow spaces in it, the chambers that hold spinal fluid, expand. Bring the astronaut home, wait a full year, and some of those chambers are still enlarged. The brain settles into a new arrangement and stays there. Nobody has a cure. Teams have tried suction trousers that pull fluid back down toward the feet. Teams have tried thigh cuffs. They help a little, and that is the whole toolkit. So the spinning ring becomes the only thing standing between 10 generations and blindness. Spin the ring, and the hill comes back. Fluid falls toward your feet again. Your heart has a job. Your eye keeps its shape, which fixes it for the people on the outer decks. Now think about everyone else. The mechanic who spends her career in the hub where the rings meet. The pilot, the storage crews, the children who float in the observation dome because floating is the best thing on board. All of them live part of their lives in the light zone, and every hour there is an hour their plumbing runs backward. And there is one more thing, quiet and awkward, sitting underneath all of it. Every fact we have about the human body and space comes from people who went up as fully grown adults, stayed a few months, and came home to a hospital. Their skeletons were already built. Their eyes were already finished. Their brains had already wired themselves in Earth's pull. The ship carries no adults from Earth after the first generation. It carries people assembled from scratch, in there, from cells that never once felt a planet. Which raises a question the doctors have started asking out loud. What happens to a person's immune system when there is nothing left in the world to fight? Roughly half the astronauts who fly are carrying a virus that wakes up while they are in orbit. It was already inside them before launch. Chickenpox, caught in childhood, never actually leaves. The virus retreats into the roots of your nerves and sleeps there for the rest of your life, held down by an immune system that checks on it every single day. Epstein-Barr does the same thing. So does the virus behind cold sores. Send that person to space and the guards go quiet. Researchers found the evidence in spit and urine. Sleeping viruses reactivating in about half of shuttle crews, shedding copies into the body sometimes for months. Most astronauts never develop symptoms. The virus is simply loose again, testing the fence, while the immune system that used to pin it down grows sloppy from stress, disrupted sleep, radiation, and the strangeness of having no ground beneath you. That is 6 months. Now open the throttle to 400 years, because the next part is where it turns strange. Diseases need crowds. Measles is the clearest example. Once measles rips through a town, everyone who survives is immune for life. To keep existing, the virus needs a steady supply of fresh children who have never met it. Feed it too few, and it burns through everybody and dies out like a fire that runs out of wood. Scientists measured that threshold using islands. They found a number. Below roughly 250,000 people, measles cannot hold on. It flares, it kills, it vanishes. A generation ship carries around 1,000. So do the arithmetic. Somewhere in the first few decades, every crowd disease on board will meet a wall of immune survivors, run out of new hosts and go extinct. The colds vanish. The flus vanish. The childhood infections that every human generation for 100,000 years has grown up fighting simply stop existing, which sounds like paradise, and it is the setup for a disaster. Your immune system arrives half-built, and it finishes itself by fighting. Children raised in scrubbed environments grow up with immune systems that misfire, attacking pollen, food, and their own tissue because the machinery is built to hunt, and there is nothing left to hunt. By the 3rd generation, that ship is full of people whose defenses have never fought anything at all. An army that has never seen a war, 400 years deep, still fully armed. And 2 things are waiting for them. The first is the ones that stayed. The sleeping viruses hide inside the crew, passed from mother to child, invisible, patient. One of them wakes up in a population with no immunity whatsoever, and it moves through the ship like a match through dry grass. The second is the destination. The whole point of the voyage is a planet. Soil, dust, whatever is living in it. The crew that finally opens that hatch will be the most immunologically defenseless humans who have ever existed, walking into a biosphere nobody has ever sampled. History already ran this experiment on Earth. Islands, ships, first contact. It never went well for the ones who had never met the germ. So the doctors on board face a decision that sounds like madness. Should they deliberately keep diseases alive, farm them, infect their own children on a schedule, to keep the immune system sharp for a planet none of them will live to see? And while they're arguing about it, something quieter is happening in the walls. The ship is growing its own life, and it is winning. On the Russian station Mir, the crew opened a panel and found the wall breathing. Behind the equipment racks, in the warm dark where condensation collected, mould had taken hold. Fungus spread across insulation. It ate into rubber seals, it chewed on plastic and wiring, and in one of the most unsettling discoveries in spaceflight history, engineers found fungal growth etching the surface of a window, working on the glass itself. The station had grown its own ecosystem, and nobody had invited it. Mir eventually carried well over 200 species of microbes that had hitched a ride from Earth, mutated in orbit, and settled into a home with no competitors, no seasons, and no predators. Crews scrubbed. The growth came back. The Russians started calling contamination a design problem rather than a cleaning problem, which is exactly what it is. Here is the part that flips the whole picture. You're a walking city. Trillions of bacteria live on your skin, in your mouth, and packed into your gut. And they do work for you. They break down food you cannot digest. They make vitamins. They crowd out invaders by taking every seat at the table. And crucially, they teach your immune system what to ignore. Take a person away from soil, animals, plants, dust, and other people's microbes, and that inner city starts losing residents. The space station is one of the cleanest places humans have ever built, and a recent survey of its surfaces found something nobody expected. The place is scrubbed of the ordinary environmental microbes that coat every doorknob on Earth. What lives there instead comes mostly off human bodies. Researchers connected that emptiness to the rashes, the odd allergies, and the immune weirdness that crews report and doctors shrug at. Their suggestion was almost funny. Make the station dirtier, add soil bacteria on purpose, build the garden back in. So the Generation ship faces two enemies pulling in opposite directions. The microbes it wants keep dying out. The microbes it hates keep thriving. And the ones that thrive have an advantage nobody can take away from them. Bacteria can produce a new generation in 20 minutes. In the time it takes a single human child on that ship to reach her first birthday, a bacterial line inside the water system runs through more generations than humanity has managed since we came down from the trees. 400 years of that, behind panels, in pipes, in the soil of the farm decks, in the crew's own guts. The microbes on board will evolve into things that have never existed. They will find new foods. Some of them will find the ship itself the way that fungus found the window on Mir. Others will find the people. And every one of those experiments runs at full speed, day and night, with no way to stop it, no fresh strains from outside to compete with the mutants, and no laboratory on Earth to send a sample to. Meanwhile, in the middle of that quietly mutating world, the first human being who has never seen the sky is about to be born. She will grow up between decks of different weight, under lamps, in air that has been through 10,000 pairs of lungs. And she will grow into something Earth has never made. The first child born on that ship will grow up in a world where the farthest thing you can look at is a wall. Start with her eyes, because this is the part that surprises people. Nearsightedness is exploding on Earth. In some cities in East Asia, roughly 8 or 9 out of every 10 young adults now need glasses to see across a street. Genetics explains part of it. The bigger driver turns out to be sunlight and distance. Children who spend hours outside letting their eyes rest on far horizons under bright natural light develop eyeballs of normal length. Children who spend their childhood indoors focused on things an arm's reach away grow eyeballs that stretch slightly too long, and a stretched eye cannot focus on anything far. Now put a child inside a metal cylinder for 18 years. The lamps are dim compared to a real sky because every watt costs fuel. The longest sightline runs a few hundred feet before the floor curves up and becomes the ceiling. There is no horizon anywhere on board. There never will be. Within a couple of generations, that entire population may need glasses. which means the ship must carry an optical factory forever, or grow a species that cannot see its own destination on approach. Her spine will surprise you too. Astronauts get taller in orbit. Take the weight off the stack of discs in your back, and they swell with fluid, and a person can gain a couple of inches in a matter of days. On the outer decks, where the spin is strongest, her spine stays compressed like ours. Every time she climbs toward the center, she grows. Every time she comes back down, she shrinks. Then there are the muscles she will never build. A body constructs exactly as much as it is asked for and no more. Bone answers loads. Muscle answers resistance. Heart muscle answers the daily work of pumping blood up a standing column of body. Raise a child at a fraction of Earth's pull, and you get a person perfectly matched to her world. Tall, slender, efficient, beautifully adapted, and permanently exiled. That is the sentence hiding inside the design. If the ship runs its habitat at anything less than full Earth weight, the children raised there can never come home. Bring one of them to this planet and her legs would buckle. Her heart would struggle to push blood to her brain. Her bones would break under a load that a toddler here handles without noticing. Islands do this. Put a species on a small island, cut it off, and it drifts. Elephants shrink. Lizards grow. Birds forget how to fly, because flying costs energy and nothing on the island is chasing them. The ship is an island. It is the smallest island in history, and the sea around it is 4 light-years wide. She will never feel rain. She will never smell a forest after a storm. Her whole sky will be a painted panel and a window full of black. And the strangest part is that she may be perfectly happy, because a horizon is only something you miss if you have seen one. Her grandparents chose this, she did not. But before any of that becomes a problem, the ship has to keep her breathing. And 35 years ago, in a glass building in the Arizona desert, 8 people discovered exactly how quickly that goes wrong. The air started disappearing, and nobody could find where it went. The air was vanishing, and the wolves had eaten it. In the autumn of 1991, 4 men and 4 women walked through an airlock in the Arizona desert and sealed it behind them. Above them stretched 3 acres of glass and steel, packed with a rainforest, a savanna, a desert, a mangrove swamp, a small ocean with a coral reef, and a farm. They intended to stay 2 years without opening the door once. It was the closest anyone has ever come to building a world. Within weeks, the instrument started reporting something wrong. Oxygen normally sits at just under 21% of the air you're breathing right now. Inside the glass, it began to slide. 1 month, then the next, for 16 months straight. It fell to 14%. That is the air on a mountain summit around 15,000 feet, and the crew was living in it, farming in it, sleeping in it. They could not climb the stairs without stopping. They struggled to finish sentences. One of them fell asleep mid-conversation. Their doctor, watching everybody's minds slow down, understood they were suffocating in slow motion, inside a building full of plants. And the mystery was worse than the symptoms. Oxygen and carbon dioxide are supposed to trade places. Anything that burns oxygen releases carbon dioxide. So if the oxygen was leaving, the carbon dioxide should have been piling up to match it, molecule for molecule. It was not. The books refused to balance. Something was stealing carbon out of the air and hiding it. It took a team with isotope instruments to catch the thief, and the answer was so simple it was humiliating. Start with the soil. The designers had loaded the farm with rich organic dirt to guarantee good harvests. That dirt was alive. Microbes in it feasted on all that organic matter, and microbes breathe. They inhaled oxygen and exhaled carbon dioxide 24 hours a day, across 3 acres. That much was expected. Plants should have grabbed the carbon dioxide back and returned the oxygen. The loop should have closed. Then look at what the building was made of. Concrete. Enormous quantities of it poured fresh and still curing. Curing concrete drinks carbon dioxide straight out of the air and locks it into stone as calcium carbonate. Permanently. The carbon went into the walls and stayed there, so the plants never got their carbon dioxide back, and with no carbon dioxide to work on, they could not make the oxygen to replace what the soil was burning. The oxygen had gone into the microbes, then into the air as carbon dioxide, then straight into the concrete, where it was never coming out. The building was drinking the atmosphere through its own foundations. By January of 1993, the crew was in real danger, and the project did the thing it had promised the world it would never do. They pumped oxygen in from outside. That is the lesson, and every generation ship designer has it tattooed somewhere. In a sealed world, every single surface is part of the biology. Paint, glue, plastic, insulation, floor, ceiling. In an ordinary building, concrete quietly absorbing carbon is just chemistry. In a sealed one, it is life support. They caught it because they had a planet outside to help. And the air was only the second worst problem in there. The first was that everybody was starving. They grew 83% of their own food, and they were hungry for 2 straight years. Take that number seriously for a second. 8 people, 3 acres, no chemical fertilizer, no pesticides, no deliveries. They grew rice, wheat, sweet potatoes, beets, peanuts, beans, bananas, and papayas. They recycled every scrap of human and animal waste back into the soil. Agriculturally, they broke records. And they still lost, on average, 16% of their body weight. 16%. On a grown man, that is a suit that suddenly hangs off him. Ribs, hollow cheeks, the look of somebody recovering from an illness. Every one of them walked out of that airlock lighter than they walked in. The missing 17% of the food was the whole story. Because a farm is a gamble on weather, and Arizona had weather. Winter arrived and brought cloud cover, week after week of grey. Sunlight is the fuel that runs the entire operation, and the sunlight dimmed. Crops underperformed, yields dropped. There was no supermarket. There was no next year to make it up. A cloudy month in Arizona is a bad mood. Inside the glass, a cloudy month was famine. Then the pests found them. Broad mites, thrips, nematode worms in the roots, cockroaches, warm, humid, no predators, no cold snap to knock the populations back. The pests exploded and ate the crops before the humans could. The crew spent hours every day on their knees, weeding and killing insects by hand, doing brutal physical labor while breathing thin mountain air on a diet that gave them almost no fat and almost no sugar. The animals went next, and this part is quietly awful. They had brought chickens for eggs and pigs for meat. Both animals eat. And the food those animals were eating was food the humans needed. So the crew did the arithmetic, and then they killed and ate the chickens. Then they killed and ate the pigs. The livestock went from being the food supply to being competition for the food supply. They grew coffee. The harvest was so small that each person got roughly 1 cup every 2 weeks. By the end, food had become the emotional centre of that world. Bananas were counted. A stolen snack was a scandal. The doctor, who had spent his career studying whether eating less makes you live longer, cheerfully reframed the famine as a health experiment, and not everyone found that funny. Now, scale it. The generation ship starts with a harder problem than they had. One team calculated it takes roughly 110 acres of farmland to feed 500 people with no resupply. Multiply by the crew that actually flies. Then remember that every acre must be lit by lamps that run on the ship's power, which means every calorie eaten on board is paid for in reactor output. And unlike Arizona, that farm has no bad weather insurance, no seed catalogue, no neighbouring county to buy grain from, and no exit. 8 people, watched by the whole planet, with engineers on call outside and a phone that worked, still came out looking like survivors of something. 1,000 people, 400 years, 10 generations of harvests and a single crop failure with no way to call anyone. But hunger was survivable. The thing that actually doomed that glass world was smaller than a fingernail, and it was already dying. Every pollinator inside that glass world died, and the humans had to become bees. The hummingbirds went first, then the honeybees, then every other insect brought in to carry pollen from flower to flower. Nobody's entirely sure why. The glass filtered ultraviolet light, and bees navigate partly by ultraviolet. The seasons were wrong. The flowers bloomed on the strange schedules. Whatever the cause, one by one the pollinators stopped existing, and the crew watched it happen with no way to stop it, which left the plants standing in a room with no way to reproduce. Flowering plants do not move. They pay insects in nectar to carry their pollen for them. Cut the courier service and the whole arrangement collapses. The trees that were already grown kept living out their lifespans, and behind them stretched a future with no seedlings in it. That ecosystem was on a countdown from the moment the last bee dropped. So 8 exhausted, oxygen-starved, underfed people picked up paintbrushes and hand-pollinated their crops, flower by flower, to eat. Then the rest of the food web unravelled. Of the 25 small vertebrate species they brought in, 19 went extinct. Roughly 40% of the 3,800 species inside that building died out during those 2 years. It was designed as an ark. It behaved like a shipwreck, and into every empty seat came the weeds. One species of ant, a globe-trotting invader called the longhorn crazy ant, had slipped in during construction. It took over. Crazy ants swarmed every biome, wiping out the other ant species, running across the rainforest and the desert and the kitchen counters. Cockroaches boomed. Katydids boomed. Broad mites and nematodes chewed through the crops from below. Morning glory vines climbed over everything and tried to strangle the rest of the plants. 3,500 carefully chosen species, curated by ecologists, collapsed into ants, roaches, and vines. The ark had turned into a vacant lot. Then there is the detail that still stops biologists cold. The trees grew fast, tall and beautiful, and they started falling over. Nobody had thought about wind. Out on a real planet, a tree spends its whole life being shoved around, and every shove tells it to lay down reinforcement. Trees build a special dense tissue exactly where the bending happens. It is why a forest can stand. In perfectly still air, under glass, the trees never got the message. They shot upward, hollow strong, elegant, and then collapsed under their own weight. Nobody knew that trees need to be pushed until they built a world without weather and watched the trees fall down. That is the true warning for a ship, and it runs deeper than bees or ants. An ecosystem is a thing you release, and then you watch what it becomes. Every living thing in there is running its own agenda, adapting, competing, dying, and the connections that matter turn out to be the ones nobody wrote down. Wind, ultraviolet light, a curing wall, a single stowaway ant. Biosphere 2 ran for 2 years and lost 40% of its life. A generation ship must run for 400. So the obvious question is whether anyone has ever done it properly. Sealed a crew in, closed the loop completely, and kept it closed. The Soviets tried, in a steel box buried in Siberia, and they got closer than anyone since. Buried under Siberia, 3 people lived for half a year on bread they grew themselves, and they still cheated. The Soviets got to this problem first. Long before the glass domes and the press conferences, engineers in Krasnoyarsk built something with no windows and no publicity. A steel box, sunk into the ground, about the size of a large apartment. They called it Bios 3, and they finished it in the early 1970s. Inside were 4 compartments, 3 tiny cabins, a kitchen, a control room. Beside that, sealed chambers of tanks and plants under blazing xenon lamps that stood in for the sun. The green half of that box did the work. Tanks of chlorella, a single-celled algae, drank the crew's exhaled carbon dioxide and pushed out oxygen. Wheat grew under the lamps and the crew ground it and baked it into bread. Vegetables filled the rest. Water passed through the plants, evaporated, condensed, and came back clean enough to drink. The garbage had a job too. Straw, roots, stems, every scrap the crew could not chew went into a furnace and burned. That pushed the carbon back into the air so the next wheat crop could use it again. In that box, even the trash was part of the atmosphere. It worked better than anything before or since. Air recycling reached effectively 100%, water recycling too. Food closure climbed to around 80%. 10 separate closure experiments ran in that box, and the longest sealed 3 people inside for 180 days. Half a year, underground, breathing air made by algae, eating bread made by lamps. And then you look at what walked in through the door. Meat. Dried meat, carried in from outside because the box could grow bread and vegetables and never grow a cow. The crew's own waste got dried and stored in containers rather than recycled back into the system, because closing that particular loop was too hard. So the most successful closed-world humans have ever built imported its protein and warehoused its sewage. 3 people, 180 days, a steel box and a bag of dried meat. That is the record. That is the high watermark. line up everything humanity has ever managed. 180 days at roughly 80% food closure with meat delivered from outside. 2 years at 83% behind glass, with oxygen trucked in when the crew started suffocating. 25 years on the space station, resupplied by rocket every few weeks, where about 90% of the water gets recycled and every gram of food arrives from a planet. Add them together and you get a simple, uncomfortable sentence. No human being has ever spent a single year inside a fully closed loop. Not once. Every experiment leaked. Every experiment took a delivery. Every experiment had a planet sitting right outside the wall ready to hand something through. The facility outlived the Soviet Union. It is still standing in Krasnoyarsk, still running experiments. A generation ship gets none of that. It needs 100% closure of everything for 400 years on the first attempt, with the nearest planet 25 trillion miles behind it. Somebody has to make up the difference, and the leading plan for doing it is stranger than anything a science fiction writer would dare put on a page. The Europeans want to feed the crew with bacteria that eat their sewage. The plan is to feed the crew on bacteria that eat their sewage, and it is real, and it has been running for over 30 years. The European Space Agency started it in the late 80s and gave it a name that sounds like a person. The idea came from staring at a lake. A lake handles waste without anyone managing it. Dead leaves sink. Things at the bottom break them down. The broken pieces feed other things. Eventually the nutrients rise, algae bloom, oxygen comes out and fish breathe. So the engineers took a lake apart and rebuilt it as 5 metal tanks in a row in a laboratory in Barcelona. Follow what happens to a single meal. The crew eats. What comes out the other end goes into the first tank, along with every stalk and root and stem the humans cannot digest. Inside that tank, bacteria that hate oxygen tear the whole mess into simple acids and ammonia. It is exactly what happens at the bottom of a pond, sped up and put in a box. Tank 2 takes the acids and hands them to purple bacteria, which grow under light. Tank 3 is where it gets clever. Ammonia is poison. But another family of bacteria has fed on ammonia for billions of years, converting it into nitrate. Nitrate is fertilizer. In one step, the crew's waste has become plant food. Tank 4 grows spirulina, an algae people already eat on Earth. It drinks carbon dioxide, hands back oxygen, and grows into edible protein. Tank 5 is the greenhouse, where actual crops close the circle, sewage in one end, bread and air out the other, a lake, folded up and bolted to a wall, and they have proved the front half works. In Barcelona, oxygen produced by spirulina in a tank has kept live rats breathing, which is the first time any European lab has run a piece of that loop with something warm-blooded on the end of it. Then comes the catch, and the catch is beautiful and horrible. You can only eat so much bacteria. Microbial cells are stuffed with the machinery of life, and that machinery is built from nucleic acids. Eat a lot of it, and your body converts the leftovers into uric acid. Uric acid crystallizes. Crystals settle in your joints and your kidneys. That is gout. That is kidney stones. It is the same reason a diet of nothing but organ meat wrecks you. So the tank that produces protein most efficiently is the one you must ration most carefully. The best food on the ship is a slow poison. After more than 3 decades of work by universities across a continent, the loop still closes only partly. A few % of the stream in the hardest steps. 3 decades of work, and the loop is still a sketch. And now stretch it. Those bacteria are alive. Alive things mutate. Every strain in every tank will drift across 400 years, and one morning in the 23rd generation, the ammonia eaters might simply stop eating ammonia. The life support is evolving. Nobody can stop it. Which almost stops mattering, because there is a simpler problem waiting. The ship is leaking. They all leak. And the one flying over your head right now has a crack that nobody has been able to close for 7 years. There is a crack in the space station, and after 7 years of trying, nobody has closed it. It sits in a short tunnel on the Russian side, a passage barely wide enough for a person in a flight suit, connecting a docking port to the module where crews sleep. In the autumn of 2019, cosmonauts noticed the pressure dropping faster than it should. They went hunting. What they found were hairline cracks along the welds, a pattern of them, rather than a single hole. The tunnel is aluminum, welded together in the 1980s for a Soviet station that was never finished, then repurposed and launched into orbit at the turn of the century. Since then it has been pressurized and depressurized, baked in sunlight and frozen in shadow every 90 minutes, and rattled by dozens of cargo ships slamming into its docking port. That is metal fatigue. Bend a paperclip back and forth enough times and it snaps. The station has done it 150,000 times, so they patched it. Then they patched it again. Sealant, captain tape, ultrasonic detectors sweeping the walls, dust tests, watching where floating particles drift. Every repair slowed the leak. Every repair failed to stop it. By early 2024, the station was losing close to 4 pounds of air every day, and NASA's own safety auditors moved the crack to the top corner of their risk chart, the box reserved for things that kill crews. Behind closed doors, officials use the phrase catastrophic failure. The workaround is almost funny. When the tunnel is not in use, they shut the hatch on it and pretend it is somebody else's problem. It is the spaceflight version of closing the door on a broken window and hoping the house holds. In June of this year, it stopped being funny. The leak surged again during a cargo operation. Russian engineers prepared to cut into the structure to reach a suspected crack, a repair with real risk of making things worse. 5 astronauts were told to put on their spacesuits and shelter inside the docked Dragon capsule, ready to abandon the station entirely. The alert lasted about 2 hours before the work was paused. Nobody evacuated, but for 2 hours, the most expensive object humans have ever built was one bad cut from being abandoned. That station is 26 years old. It was designed to last 15. Now hold both numbers in your head. 26 years produced a crack that 7 years of the best engineers on Earth could not seal. The generation ship must hold pressure for 400, and the ship has a problem the station does not. Hydrogen and helium, the smallest atoms there are, walk straight through solid metal. They slip between the atoms in the wall and drift away into the dark. It happens slowly enough that nobody on a 2-year mission would notice, and over 4 centuries the arithmetic turns brutal. Then there is the deeper trap. The station gets rescued. Every crack it grows, every pump that dies, every filter that clogs is answered by a rocket from a planet with factories on it. Cut that rope and the ship has to fix itself. All of it. Forever. Somebody actually calculated what that would take. The answer is a repair every second and it never stops. Somebody sat down and worked out the maintenance schedule for a ship like this, and the answer broke people's brains. Several components detected, replaced or repaired every second for centuries. Read that again slowly because the instinct is to assume a typo. A light bulb every second, a valve every second, a sensor, a seal, a pump bearing, a length of wire, a circuit board, a filter, a fan. Found, diagnosed and fixed one after another without pause, while the crew sleeps, while the crew eats, while 10 generations are born and buried. The number comes from ordinary arithmetic, and that is what makes it terrifying. Every manufactured object has a failure rate. Give it enough time and it fails. Now count the objects in a machine 36 miles long. Count all of them, down to the smallest. Every fastener, every weld, every connector, every valve seat, every strand of wire in a wiring loom that could reach around the Earth. You are into the hundreds of billions. Take 100 billion parts. Give each one a lifetime of, say, a few decades. Divide the failures across the seconds in 400 years, several per second. The arithmetic never blinks. Nobody has built a maintenance system remotely like it. Nobody has built one 1,000 times smaller. Compare that to what we manage today. The space station carries a few million parts, and crews spend a serious slice of every working day on repairs. Filters, pumps, toilets, fans, a treadmill, an oxygen generator that fails often enough that they keep spares. 250 miles from a planet with a supply chain behind them. The ship has 30,000 times the parts and no supply chain at all. So the answer has to be robots. Swarms of them, crawling through the walls, listening for the ultrasonic whisper of a crack, printing a replacement, swapping it in before anybody notices, which lands you in the oldest trap in engineering. The robots break too. They wear, they jam, they lose calibration. So build robots that fix the robots. Those break. Build a third layer. And now you are stacking machines on machines. and every layer adds parts, and every part adds failures, and the pile grows faster than the reliability does. Somewhere in that stack a human has to stand, holding a wrench, understanding what the machines are doing, which drags in a problem nobody can solve with more hardware. The person holding that wrench in the year 2300 was born in a corridor. She learned from someone who was born in a corridor, who learned from someone else born in a corridor. Between her and the engineer who designed that pump lie 8 generations of teaching, copying, remembering, and getting slightly bored. And that is the honest shape of the maintenance problem. It is a knowledge problem wearing an engineering costume. The ship is a machine that must run for 400 years, maintained by people who have never seen the factory that built it, never met anyone who did, and cannot ask. But suppose you solve it. Suppose the robots hold and the crew stays sharp. You still have to answer the dumbest question in the whole design, and it has broken every plan so far. Where does the new part actually come from? Try to build a smartphone alone on a desert island, and you will die of old age holding a rock. That thought experiment is the reason the spare parts question is the hardest one in this entire design. Start simple. A bolt shears. You need a new bolt. To make a bolt you need steel. To make steel you need iron. Or carbon, a furnace hot enough to melt rock, and someone who knows the recipe. So the ship must carry ore, or carry the finished bolt, or carry a mine. The third-place team in that design competition picked the mine. They hollowed out an asteroid and built the habitat inside it, so the crew flies with a mountain of raw metal wrapped around them. Dig the wall, feed the furnace, cast the part. A starship with a quarry in the basement. That works for bolts. Now try a chip. The processor running the life support on that ship is a slab of silicon with billions of switches carved into it at a scale smaller than a virus. Making one requires silicon purified beyond almost any substance on Earth, exotic gases, dozens of ultra-pure chemicals, and a lithography machine assembled from hundreds of thousands of components, built by a supply chain that spans continents and thousands of separate companies. No factory on Earth can make a chip by itself. The planet makes chips. So the ship has 3 options, and every one of them is bad. Carry 4 centuries of spare electronics and watch them rot. Chips degrade sitting still. Aluminum grows whiskers. Solder creeps. Circuit boards absorb moisture. Cosmic rays flip bits in memory that nobody is using. The spare you sealed in a box in the year 2100 may be dead by the time somebody opens it. Build a chip factory on board, and you have to fly an entire industrial civilization to another star, along with the thousands of specialists who keep it alive. Give up on advanced computers, and you are steering a fusion rocket with mechanical switches. Levers and gears at 1/10 of light speed. That is the moment the economics arrive, and they are savage. A recent review of ships like this priced out the whole idea and concluded that the resources involved push it beyond any plausible economy until somewhere after the year 2300. The same review pointed out the awkward possibility that by then somebody will have invented a better way to travel, and the enormous arc will have been obsolete before it was ever finished. Every screw, every seal, every gram of copper, lithium, and rare earth, every ounce of the medicine that 10 generations will need, or the pharmacy to synthesize it, or the plants it is extracted from and the chemists who know how. The ship must carry the periodic table and the knowledge to use it. All of it. On day 1. That is what the word closure actually means. It means the entire industrial output of a planet, folded down small enough to fly. And once you have packed all of it, the shielding, the mine, the foundry, the farm, the hospital, the library, you have to admit that the whole cargo is still soft. Because something out there goes through steel like it is not there. And the tragedy is that armor makes it worse. The first instinct is to build a thicker wall, and the wall is what kills you. Out in the dark, space is full of bullets. Somewhere in the galaxy, a star exploded, and the blast flung the wreckage of atoms outward at close to the speed of the light. Bare atomic nuclei. Hydrogen, mostly, and helium, and a small savage fraction of heavy things. Iron, nickel, silicon. They have been flying ever since, and they are everywhere, and they are coming through you at this moment. Your atmosphere and your planet's magnetic field are eating them for you. Step outside that shelter and the rain starts. A single iron nucleus at that speed is a very small cannonball. It rips a tunnel through your body. It smashes through cells in a straight line, tearing electrons off every molecule it passes, leaving a track of shredded machinery behind it. One particle can slice through the nucleus of a cell and cut both strands of your DNA at once, which is the kind of damage your repair enzymes have real trouble with. Fire enough of them through a brain over enough years, and you get cognitive decline that shows up in animal studies as memory loss and confusion. So you build a wall, aluminum, thick and solid, and you have just made it worse. Watch what happens when that iron nucleus hits your armor. It slams into an aluminum atom at half the speed of light and both of them shatter. The energy has to go somewhere, and it goes into fragments. Protons, neutrons, and a spray of exotic particles blast out the far side, spreading like a cone. One bullet enters the wall, a shotgun blast comes out. That is called a secondary shower, and thin metal shielding is a machine for making them. The crew behind that wall is now taking more hits than they would have taken standing naked in the vacuum. The fix runs against every instinct. You want the lightest atoms you can find because a hydrogen nucleus is a single proton, and there is very little left to shatter. So the best armor in the universe is water. Plastic. Waste. Wet, soft, boring stuff stacked meters deep. That is why the ship weighs billions of tons. That is why the winning design tucked the sleeping quarters behind the water tanks and the sewage. On a starship, the trash is the castle wall. Magnets sound clever, and magnets have a hole in them. A magnetic field can bend a charged particle away. Perhaps half the atoms out there are electrically neutral, and a magnet may as well be a poster on the wall. Then there is the number that ends the conversation. Most cosmic rays carry modest energy, and a fraction of them arrive with energy so absurd that no shield anyone can imagine will touch them. They pass through meters of rock like it is open air. They pass through the ship, they pass through the crew, and they keep going. So the answer is thickness, and luck, and the fact that most of them miss, for 400 years. But every one of those particles came from somewhere else, thrown by something that died a long time ago. The ship carries a weapon of its own, because at 1/10 of the speed of light a speck of dust hits like a bomb. A grain of sand is about to hit the ship with the force of 5 tons of dynamite. Interstellar space is empty in the way a desert is empty. Almost nothing is there, and the almost is what gets you. Scattered through the dark are grains of dust, most of them smaller than a bacterium, thrown out by dying stars and drifting for millions of years. On any ordinary day they are harmless specks. You could stand in a cloud of them and feel nothing. Then you drive into them at 1/10 of the speed of light. Speed is the whole trick, and the arithmetic is savage, because energy climbs with the square of how fast you go. Double your speed and you quadruple the punch. Multiply your speed by 30,000, which is roughly what a fusion ship does compared to a car on a highway, and a harmless speck becomes something else entirely. Run the numbers on a single grain of sand, about the weight of a fly's wing. Hit it at 1/10 of light speed and it delivers the energy of roughly 5 tons of high explosive. A pebble the size of a pea, weighing 1 gram, arrives with about 100 tons of dynamite behind it. The ship has no armor for that. Nothing does. The only defense is a bet that space is empty enough. But the pebbles are the rare event. The steady one is worse in a slower way. Across the crossing, every square yard of the nose will be struck by billions of microscopic grains. Each one hits and vaporizes, blowing a crater smaller than a bacterium out of the hull. One is nothing. Billions of them arriving for 400 years without pause is a sandblaster running against the front of your world. Slowly, atom by atom, the nose erodes, which explains the shape of the winning design and the thing that looks like a flaw. Why build a ship 36 miles long and only 4 miles wide? Why taper it to a narrow point? Because the front is the only part that gets hit. At that speed, everything comes from straight ahead. The sides are safe, the back is safe. Every impact concentrates on a tiny disc at the very tip of the vessel, and so the engineers made that disc as small as they possibly could, and then piled everything they had in front of it. The nose is a sacrifice. It is designed to be destroyed slowly, layer by layer, and replaced. The third-place team took the idea further and flew inside a hollow asteroid, letting a bell of solid rock take 4 centuries of blasting. Their shield carries repair robots to patch the pits, and layers underneath that spread the shock of a hit sideways instead of letting it punch through. So now the ship has a plan. Fly behind a rock, sacrifice the front, accept the erosion, pray about the pebbles, and it still leaves the worst part untouched. Dust is rare. Space has something in it that is 100,000 times more common, sitting in the path of every single mile of that journey, and it cannot be dodged because it fills everything. Hydrogen. Loose atoms, one every few cubic inches, drifting cold and slow and harmless, until you fly into them at 30,000 kilometers a second. At that point, the emptiness stops being empty. It turns into a weapon aimed permanently at the front of the ship, and the crew built it themselves. The ship is a particle accelerator, and the target is the crew. Interstellar space contains hydrogen, roughly one atom for every few cubic inches out here, drifting at whatever pace the galaxy left it. Sitting still, it is the least dangerous substance imaginable. You could swim through a room of it and never know. Now fly into that room at 30,000 kilometers per second. Physics does not care who is moving. From the ship's point of view, it is parked, and the hydrogen is coming at it at 1/10 the speed of light. Every atom in the path arrives carrying millions of electron volts of energy. That is the same neighbourhood as the beams that hospitals use to burn tumours out of people. So the front of the ship flies into a permanent, unstoppable proton beam. And the numbers are brutal. Every second, trillions of those atoms strike each square yard of the nose. That flux never dips. It never pauses. There is no shelter behind a planet, no night side, no 11-year cycle. It runs for 400 years, and it always comes from exactly the same direction. Push the speed higher, and it stops being survivable at all. Researchers modelling this found that above about a third of light speed, unshielded electronics facing forward degrade to junk in minutes. Minutes. The circuit boards cook. Here is the cruelest detail, and it kills the elegant solution. Every science fiction ship deflects radiation with a magnetic field, and magnets do work on charged particles. Bend the path, push them around the hull. Done. Except roughly half the hydrogen out there has kept its electron. It is neutral, it carries no charge at all, and a magnetic field is invisible to it. The neutral half sails straight through the deflector, like it was never switched on. One team proposed answering that with something that sounds like a supervillain's blueprint. Put a machine at the very front whose only job is to strip the electrons off incoming atoms before they arrive, turning the neutral half into charged particles, and then bend those away with a magnet behind it. Rip apart the fabric of space in front of you so that your force field has something to grab. The alternative is simpler and heavier. Fly behind meters of solid matter and let the beam chew on it forever. Now stack up everything sitting in front of that nose. Cosmic rays from dead stars coming from every direction at once. Dust grains erupting like small bombs. A hydrogen beam of the ship's own making blazing against the front hour after hour, century after century. And underneath all of it, the ship's own reactor throwing neutrons at everyone from the inside. 10 generations of human beings will live inside that, sleeping behind their sewage tanks. Which raises the question that quietly decides the entire mission. Adults can absorb some of this. Adults are finished. Cells that get damaged are replaced. Damage that accumulates has decades to turn into cancer, and the crew might reach old age first. An embryo has no such luxury. An embryo is a handful of cells, dividing, copying instructions that every later cell in that body will inherit forever. So somebody flew mouse embryos into orbit to find out what happens. The results came back, and they were not what anyone expected. 6,000 mouse embryos went into orbit to answer one question, and the answer split the scientists who ran it. An embryo is the master copy. Every cell in a finished body is a photocopy of a photocopy of a photocopy, tracing back to a handful of cells that divided in the first few days. Scratch an adult skin cell and the body throws it away. Scratch the master copy and every page printed afterward carries the scratch. So the most important experiment for a generation ship is embarrassingly basic. Can a mammal even begin? A Chinese team went first. They loaded thousands of mouse embryos onto a satellite, froze the moment at the 2-cell stage, and let them develop in orbit while cameras watched. The embryos grew. That part worked. They divided, they organised, they reached the stage where a ball of cells starts sorting itself into the part that becomes an animal and the part that becomes a placenta. But fewer of them made it than should have. The ones that did carried broken DNA, and the chemical tags that sit on top of genes, the switches that decide which instructions a cell reads, had been stripped away in patterns nobody wanted to see. Then the team did the clever thing. They repeated the whole experiment on the ground. Same embryos, same dish, normal gravity, and one difference. They exposed them to a tiny trickle of radiation, 0.002 of a gray, spread across 64 hours. A dose so small it sounds like a rounding error. The ground embryos came out damaged in the same way as the ones from space, which pointed the finger away from weightlessness and directly at radiation. And that finding lands like a hammer on the whole design, because you can spin a ship to make gravity. Radiation you can only hide from. Then a Japanese team ran it again on the space station and complicated everything. They thawed embryos in orbit, grew some in free fall and some in a small centrifuge that faked Earth's pull, and compared them. The embryos in free fall developed into healthy-looking blastocysts, correctly organised, with gene activity that matched the controls back on the ground. Their conclusion was blunt. Gravity is optional for the first few days of a mammal. Meanwhile, they were doubtful about the radiation story, because the doses in these experiments sit hundreds of times below the level known to kill a mouse embryo. So the field has two results, and a real argument. One team saw damage and blamed radiation. Another team saw healthy embryos and questioned whether such a whisper of radiation could do anything at all. That argument is the whole point. The most important biological question in the history of interstellar travel has been tested exactly twice, on mice for a few days, and the experts came out disagreeing. A generation ship needs that question answered for 10 generations of human beings, and it needs the answer before launch because there is no correcting it afterward. A ship that discovers in year 60 that its children develop wrong has already killed everyone on board. They just have not finished dying yet. And all of that is about a ball of cells in a dish in the first 4 days. Nobody has come close to testing the rest of it, because in 70 years of spaceflight, with a laboratory circling this planet the whole time, not one mammal has ever been conceived, carried, and born off Earth. Not one. And when they tried, the results were grim. Pregnant rats have flown in space. What came back was a warning nobody has been able to explain away. Start with what worked, because something did. Male mice lived on the station for 35 days, came home, and fathered perfectly healthy pups. So the male half of the equation survives a month of weightlessness and radiation with nothing obviously wrong. Now the other half. The Soviets and later the Americans flew pregnant rats. Timing turned out to be everything. Send a rat up in the middle or late part of her pregnancy and she delivers. The pups arrive, they live, and then you weigh them and count them and follow them, and the picture darkens. Smaller birth weights, smaller litters. More of the newborns die in the first days. The mothers had spent a critical stretch of pregnancy without any pull on their bodies, and it showed up in their children. Then they tried it early. Rats exposed to spaceflight during the earliest part of gestation failed to produce offspring at all. Read that plainly. The pregnancy did not survive. Nobody has fully explained why. The first days are when the embryo has to attach to the wall of the womb, a process that involves fluid, chemistry, position, and timing all cooperating. Change the environment during that window and the whole thing quietly fails. And that early window is exactly the part of pregnancy that a woman is least likely to know about. Now think about birth itself, and how much of it leans on the planet. Labour works with gravity, using the weight of the baby to help. Your blood volume climbs by nearly half during pregnancy, and your heart handles that in a body built for standing. Your skeleton hands over calcium to build another skeleton, which is a serious withdrawal from an account that spaceflight is already draining. Hemorrhage after birth is the leading cause of maternal death on Earth, in hospitals with surgeons and blood banks and helicopters. Put that in a rotating ring, 4 light years out, with whatever surgeon the ship happens to have that decade. So the spinning solves it, in theory. Give the Mother Earth's pull and her body behaves like a body. Except we have never checked. The centrifuge that would answer this, a spinning module big enough to gestate mammals at different weights, has been proposed for decades and never flown. Here is where the record stands, 70 years of spaceflight. A permanently crewed laboratory in orbit for 25 of them. Billions of dollars, 600 people flown. And no mammal has ever been conceived, carried to term and born beyond this planet. Not a mouse, not a rat. Nothing. The single most important fact about human survival off Earth is simply unknown, and nobody has scheduled the experiment. A generation ship is a bet that it works. It is a bet placed with 1,000 lives, made by people who will be dead before the answer arrives. So the mission plans the way you plan for a coin flip. You cannot afford to lose. It carries backup, frozen backup, thousands of strangers sealed in liquid nitrogen waiting. But first the ship has to survive a problem that sounds impossible in a place that is 3 degrees above absolute zero. The ship is going to overheat. Space is a few degrees above absolute zero, and the ship is going to cook itself alive. That sentence sounds broken. Everyone knows space is cold. Step outside without a suit and the cold kills you, in every film ever made. The films are wrong, and the reason is sitting in your kitchen. A thermos keeps coffee hot for hours using one trick. Between the inner wall and the outer wall, the manufacturer pumps out the air. Heat needs something to move into. It flows through solids by touch. It rides away in moving air or water. Take away the stuff, and the heat has nowhere to go, and your coffee stays hot. Space is a vacuum. Space is the inside of the thermos. Out there, nothing touches you. There is no air to carry heat off your skin, no water to pull it away, nothing at all to receive it. The temperature of empty space is meaningless to you because temperature needs matter, and matter is exactly what is missing. So the ship has one exit for heat, and only one. It has to glow. Every object radiates. Your body is pouring infrared light into the room this second. It is a slow, weak way to dump energy, and in a vacuum it is the only way that exists. Now add up what has to be dumped. Every single watt used on that ship turns into heat. All of it. The computers, the pumps, the motors that spin the rings, the reactor, and the monster in the room, the one that dwarfs everything else, is the farm. Crops need light, and light on that scale is enormous. Feeding a crew takes over 100 acres of growing surface lit brightly enough to fake a summer day. Run the arithmetic and the lamps alone draw over 100 million watts. Every watt of it lands on a leaf, becomes heat, and stays inside the hull. A surface at room temperature radiates roughly 450 watts per square yard. Divide 100 million by that. The ship needs radiator fins covering hundreds of acres. Read that again. To feed the crew, the ship must wear a set of glowing panels larger than the farm they feed. And those panels are the most fragile thing on board. They have to be thin, because thickness is mass. They have to be huge, because area is the only lever. They have to be exposed, hanging out in the open, which puts them directly in the path of everything from chapter after chapter of this story. The dust, the hydrogen, the cosmic rays. The most delicate structure on the ship is the one thing standing between 10 generations and a slow bake. Lose the radiators and nothing dramatic happens at first. The temperature creeps up, a degree a week. Then the crops fail because plants are fussy about heat. Then the electronics start dying. Then the people. The only exit is the glow, and if the glow stops, the ship becomes an oven with a fusion reactor bolted to the back of it. So the engineers now have their machine. Shielded, spinning, farming, glowing, repairing itself, 400 years of it. All that is left is to decide who gets on board. And that is where the scientists started shouting at each other, because their answers differ by a factor of 140. One scientist says 98 people, another says 14,000. They are looking at the same problem. That gap is a factor of 140. One of them wants a village, the other wants a small city. Everything about the ship, the mass, the farm, the radiators, the fuel, hangs on which of them is right. Start with the low number, because the way it was calculated is beautiful. An astrophysicist in Strasbourg got frustrated reading science fiction about generation ships and decided the field was naive. So he wrote a program. It takes a crew, and then it lives their entire voyage, person by person, year by year. Every individual has an age, a sex, a fertility that rises and falls with time, a chance of dying that changes as they get older, a chance of finding a partner, a chance of conceiving. Then it runs the whole thing again, and again, thousands of times with the dice rolling differently each run, because a single simulated voyage tells you nothing. 1,000 of them tell you the odds. His answer for a crossing lasting 6,000 years came out at 98 settlers. 98 people, fewer than a school, enough to start humanity again on another world, and the number comes with conditions that read like a prison rulebook. That crew survives only under what he politely calls adaptive social engineering. The population gets evaluated every year. Who may have children is restricted. How many children they may have is restricted. Who pairs with whom is steered generation after generation to keep the family tree from folding in on itself. Under those rules, he showed the population could stay healthy essentially forever. Now the other camp. An anthropologist in Oregon looked at the same problem and reached 14,000, with a comfortable figure closer to 40,000. His objection is one sentence long, and it is devastating. A genetic minimum ignores everything that actually happens to real populations, because 98 is the answer to a narrow question. How few humans can carry enough genetic variety to avoid the diseases of inbreeding? It is a question about DNA in a spreadsheet. Real populations have to survive events. An epidemic sweeps through and takes a third of them. A reactor accident kills the shift working that deck. A bad decade produces almost no daughters, purely by chance, and 30 years later there are no mothers. On Earth, a village that gets unlucky is rescued by the next village. There is no next village. Then look at the skills. That crew has to include surgeons, fusion technicians, geneticists, farmers, teachers, materials chemists and psychiatrists. Each one needs a backup because people die. Each backup needs a student because a career lasts 40 years and the voyage lasts 400. 98 bodies cannot hold a civilization's knowledge, no matter how carefully you breed them. So the design competition split the difference and demanded 1,000, give or take 500. The winning cocoon carries room for over 2,000. Nobody in the field agrees with anybody else, and every one of them has the math to prove it. Which leaves the question everyone actually wants answered. What happens if you go smaller? If 98 is the floor, what is waiting underneath it? He ran that simulation too. At 32 settlers, the chance of arriving alive drops to exactly 0. On a small island in the Pacific, 1 in every 10 people sees the world in grey. Around the year 1775, a typhoon hit the atoll of Pingelap. The wind and the water took almost everyone. When it passed, roughly 20 human beings were left alive on that scrap of land, and they rebuilt the population from there. One of the survivors was the chief, and the chief carried a gene. He was healthy. He could see colours perfectly well. The broken gene sat in him as 1 copy out of 2, silent, doing nothing, the way broken genes sit inside all of us right now. It takes 2 copies to cause harm, and he only had 1. But his descendants married his other descendants because there was nobody else. Today, on Pingelap, roughly 1 person in 10 is completely colourblind. Total, rather than the ordinary red and green confusion. A world of grey with eyes so sensitive to light that daytime is painful, and vision so poor that reading is a struggle. Elsewhere on Earth, that condition strikes about 1 person in 30,000. 1 storm, 20 survivors, 250 years, and 1/10 of an island lives in a black and white film. That is the founder effect, and it is the reason the crew number matters more than the engines. Everybody reading this carries broken genes. Estimates say each of us hauls around 1 or 2 mutations that would be lethal if we had 2 copies of them. You are fine because you have a spare. Your partner has different broken genes, so your children get a working copy of everything from at least one of you. That system works because the world is enormous, and the odds of meeting your genetic twin are almost nil. Shrink the world to a corridor. Run the simulations and watch the collapse. Start a voyage with 150 people and let 200 years pass, and the population crashes to 1/3 of what it started as, with inbreeding damage running through everyone left. A crew that departed as 150 arrives as about 50. The ship survives. The gene pool does not. Take it down to 32, and the model stops giving percentages. It gives a 0. Because by the 2nd generation on that ship, every child is marrying a cousin. By the 3rd, cousins are the optimistic version. The broken genes that everyone carried quietly at departure start meeting their matching copies over and over, and the birth defects arrive in waves. 32 people is a family reunion with a 400-year timer on it. which is why the honest answer to the crew size question sits somewhere between 1,000 and 40,000, and why the whole ship has to be a city. But there is a cheat available, and it is one of the strangest ideas in this entire field. You do not have to fly the genes inside living people, freeze them. Sperm, eggs, embryos, sealed in liquid nitrogen, packed into the most heavily shielded room on the ship, thousands of donors who never board, never age, never argue, never die. Genetic strangers, riding along in a tank, waiting for a great-great-grandchild to need them. And someone has already tested whether it works. They kept mouse sperm in orbit for 6 years and made healthy babies out of it. Mouse sperm sat in orbit for 6 years, came home and made healthy babies. That experiment matters more than it sounds, because it is the first real evidence for the strangest passenger list ever proposed. A team freeze-dried mouse sperm, flew it to the space station, and left it there in storage while cosmic rays passed through it, day after day, for nearly 6 years. Then it came down, they rehydrated it, and the pups born from it were normal, healthy, fertile. Run the damage rate forward, and the researchers estimated that sperm could survive up in orbit for roughly 200 years, which is exactly half of what the voyage needs. Hold that thought. Here is the plan it belongs to. The crew that walks aboard is a few hundred people. Their genes are the genes the ship has forever, and every generation shuffles the same deck. So the astrophysicist who calculated the minimum crew added a component to his design that has nothing to do with engines or farms. A tank of frozen strangers. Sperm, eggs, embryos. Thousands of donors who never board, never breathe the recycled air, never argue about the rations. They ride in liquid nitrogen in the most shielded room on the ship, buried behind meters of water and rock, deeper than the crew quarters. They are the ship's genetic savings account. Think of a seed vault. On an island near the Arctic, humanity keeps a bunker of seeds from every crop we grow, in case a blight or a war wipes a species out. The ship carries the same idea, made of people, and it changes the arithmetic completely. A crew of a few hundred with a bank of 10,000 donors has the genetic variety of a small city while feeding only a village. Every few generations, the doctors reach into the tank and introduce blood from Earth, from someone who died 4 centuries ago, and the family tree stops narrowing. Now the problems. Freezing stops biology. It does nothing to physics. A frozen embryo cannot repair itself, because repair requires enzymes, and enzymes require a cell that is running. Every cosmic ray that punches through that tank cuts DNA that will stay cut. Damage accumulates for 400 years with nothing to answer it, which brings back the number. 200 years of good storage for a 400-year crossing. The bank may be dead before anyone needs it. Then there is the part that a spreadsheet cannot hold. A child conceived in the year 2300 from a vial has a mother who was born on Earth, who saw oceans, who chose to donate and then went home to a life that ended centuries before her son existed. That boy will grow up knowing his mother's name and knowing she is dust on a planet he will never see. Half the ship's family tree will be ghosts in a tank, and someone has to decide when to open it. Someone has to decide which donors get used and which stay frozen. Someone has to decide who on board is allowed to have a baby the ordinary way at all. Because on a ship where every mouth costs oxygen and every gene matters to everyone, having a child stops being a private decision. It becomes a public one, reviewed, approved, scheduled. And that is the moment the ship stops being a spacecraft and becomes a very small country with very strict laws. On this ship you have to apply for permission to have a baby. That sentence should make your skin crawl, and the arithmetic behind it is airtight, which is the horrible part. Go back to the model that produced the famous number. 98 settlers arriving healthy after 6,000 years. That result comes bundled with rules, and the researcher lists them plainly. Yearly evaluation of the population, restrictions on offspring, constraints on breeding. Translate that from scientific language. Every year, somebody counts you. They look at the ship's age structure, the sex ratio, the number of women in their fertile years, the food supply, and how tangled the family tree has become. Then they issue decisions. This couple may have a child. This couple may have two. This couple, whose grandparents were siblings on paper, may not have children with each other at all, and here is the vial they will be using instead. That is the price of 98 people. Somebody has to run the herd, and the rules get more invasive the closer you look. Timing gets managed, because a generation ship needs births spread evenly. Bunch them up and you get a wave of children who all need teachers at once, then all need jobs at once, then all get old at once and leave nobody to run the reactor. So the ship needs a birth schedule, and a birth schedule means telling a 22-year-old woman that her turn comes in 9 years. Age windows get enforced because fertility fades and genetic damage rises with the age of the parents. Partner choice gets steered, because the whole point is to keep the deck shuffled. Fall in love with the wrong person, and the geneticist has an opinion about your children. Now imagine growing up inside that. You're 16. You know exactly which file you came from. You know your genetic value to the ship because it is a number in a file and everyone has one. You know that the boy you like has a similar profile to yours, which means the two of you together are worth less to the ship than either of you paired with somebody else. There is no eloping. There is no moving to the next town. Every generation on that ship inherits a body of law written by people who have been dead for centuries, aimed at people who will not be born for centuries more, and enforced on the only humans who never got to vote on it. And the strangest possibility of all is that they might like it. Grow up inside a system, and it becomes furniture. The child who has never seen a horizon does not mourn horizons. The child raised where reproduction is a civic duty may find our arrangement grotesque. Billions of people choosing at random, having children by accident, with nobody checking anything. That is the honest tension in this whole design. To survive the voyage, the ship must control the most intimate thing a human being does. And to want to survive the voyage, the crew has to be the kind of people who accept that. Which means the selection starts long before launch. The winning design was blunt about it. Before anyone boards that ship, the candidates and their descendants have to prove they can take it. They proposed locking them in Antarctica for 80 years. The plan is to lock the crew in Antarctica for 80 years first. That is a real proposal from the design that won. Before anyone climbs aboard, the candidates move to an isolated colony on the ice and stay there. For 70 to 80 years, long enough that the people who walk onto the ship are the grandchildren of the people who walked onto the ice. The training program outlasts a human career. It outlasts most marriages. The whole point is to find out whether a family line can take it before you bet a starship on the answer. And they proposed it because of what isolation does to people, which we have measured repeatedly, and it is ugly. Start with the ice, because Antarctica has been running this experiment for decades. When the last plane leaves for the winter, a crew is sealed in for months, with no rescue possible until the weather breaks, and a pattern shows up so reliably that doctors gave it a name. Sleep falls apart, tempers shorten, concentration slides, people forget things. Some of them develop a symptom the crews describe among themselves, a habit of stopping mid-task and staring at nothing for minutes at a time. They call it the long eye. Then there is a rhythm that shows up in almost every confined mission, and it is beautifully strange. Morale holds at the start because everything is new. It holds at the end because the end is coming. It collapses in the third quarter, right after the halfway mark when the novelty is dead and the finish line is still impossibly far away. Now do that arithmetic on a 400-year voyage. The third quarter of that trip runs for a century, and nobody living through it will have seen the launch or lived to see the arrival. They are the generation with no memories of Earth and no hope of the destination. Their entire lives happen in the middle of somebody else's journey. The Russians ran the closest thing we have to a real test. 6 men sealed in a mock spacecraft in Moscow for 520 days. They came out fine in the sense that they came out. But the data underneath was disturbing. Most of the crew developed problems with sleep. One man's body clock came loose from the schedule entirely and drifted, so that he was awake while his crewmates slept, alone in a metal tube for months. Another slid into chronic exhaustion. And across the whole mission, the crew moved less and less, spending more time lying down month after month, a slow retreat from being alive. 2 of the 6 accounted for most of the friction on board. 520 days, 6 volunteers. Hand-picked, screened, monitored, paid. With a door they could open if it got bad enough. The ship carries 1,000 people who never volunteered for 140,000 days, with no door. So the Antarctic plan makes brutal sense. Take 3 generations, freeze them in place, watch them fight and reconcile and raise children, and bury parents in a box at the bottom of the world, and if the 3rd generation still works, launch them. The trouble is that history has already run a version of this test in a glass building in Arizona. The crew split in half and stopped speaking, and then it got much worse than that. 2 of the original crew came back in the night and broke the world open on purpose. Start with the first mission, because the crack ran through it from early on. 8 people, sealed in glass, hungry, breathing thin air, working brutal hours in front of television cameras. Within months they had split into 2 groups of 4. The split hardened. They kept the systems running, because the alternative was dying, and they were professionals about the machines. Socially they were finished. 2 factions, sharing 3 acres, passing each other in corridors for the better part of 2 years without speaking. One crew member later described being spat at by another. 8 people, volunteers, screened, famous, watched by the whole planet, with a phone. Now the sequel, which almost nobody knows. The second crew went in during 1994. Out in the world, the project's ownership had turned into a war, management had been replaced, and 2 members of the original crew believed the new operators were about to endanger the people inside. So they drove out to the site in the dark in April and broke in. They cracked the airlock doors, they opened the vents. In minutes, the sealed world that had taken years and hundreds of millions of dollars to build was breathing Arizona air like an ordinary greenhouse. The most ambitious closed ecosystem ever constructed was deliberately unsealed by 2 of the people who had lived inside it. Sit with that. The threat to the world under the glass came from the ones who understood it best, because they cared, because they were furious, because they were human. Now take the door away. That is the part of the generation ship that no engineer can spec. Somewhere in 400 years, somebody on that ship is going to want something badly enough to reach for a valve, and the ship has no answer for them. Ask a simple question. What do you do with a murderer? Exile is the oldest punishment we have. Put the dangerous person outside the walls. The ship has no outside. Every airlock leads to the thing that kills you in seconds, which makes exile a death sentence, and makes every crime a capital crime. So execute them. On a ship where the population is calculated to 2 decimal places, where every person is a set of genes the mission cannot replace, and where the geneticists already have a plan for that individual's grandchildren, killing a criminal damages the mission more than the crime did. Then imprison them. In a place where every square yard is farm or shielding or machinery, where every meal is a calculation, feed and house a person who produces nothing for 50 years along with the guards. Every road out of that argument ends at a wall. The ship is the only country, the only court, the only press, and the only jail there will ever be. Whoever holds the reactor and the life support on that ship holds absolute power over every human being alive, and their children inherit it. Which is a recipe for a dynasty, or a coup, or both. The designers knew it, and their answer is the boldest idea in the entire competition. They decided the ship needs a constitution that is designed to be torn up. One team proposed a constitution designed to be torn up on a schedule. Think about what the founding generation is actually doing when they write the rules for that ship. They are legislating for people who will be born 300 years later, on a vessel those legislators will never see arrive, in a situation none of them can imagine. Every constitution on Earth has the same problem, and Earth has escape valves. Courts reinterpret, legislatures amend, voters throw people out, and when a country goes badly wrong, its citizens can leave, or the world can lean on it, or somebody invades. The ship has an escape valve made of vacuum, so one entry in the competition proposed something that sounds like a joke, and is actually the most serious idea in the pile. Build the rewriting into the law itself. On a fixed rhythm, the entire constitution goes into suspension. Every generation gets a scheduled window in which they take the document their great-grandparents wrote, argue about it, cut what has rotted, and hand the new version forward. A constitutional sabbatical. Planned obsolescence for the rules of your world. Every generation gets to fire its ancestors. because the alternative is worse. Leave the founding law untouched and the crew of the year 2400 lives under clauses written by strangers who are reacting to a launch they cannot remember, with a technology they no longer use, for a mission they never chose. The winner went in a different direction. Their ship is governed by people working alongside an artificial intelligence sharing the job, which raises its own question. The intelligence never forgets, never tires, and never dies. So across 400 years it becomes the most experienced entity on board by an enormous margin. At what point are the humans advising it? And then there is the part of the designs that surprises everyone. Every serious entry reserved physical space for religion, rooms for worship, rooms for grief, rooms for celebration. The runner-up went further and designed the clothing, because clothes are how people say who they are and who they belong to. One entry mapped rites of passage into the architecture so that the corridors themselves mark the difference between a child and an adult. That sounds like decoration until you remember what the ship is asking of people. Give up the planet, give up the sky, give up the freedom to have children when you want. Spend a life maintaining a machine so that people you will never meet can land somewhere you will never see. That request needs meaning behind it, and meaning is manufactured in rituals, stories, songs, funerals, and holy days. A ship that runs out of meaning stops running, no matter how well the reactor works. Despair is a life support failure. It only takes longer. So the plan is a society with a rewritable constitution, a machine partner that never dies, farms, temples, funerals, and a birth schedule. 10 generations of it, argued over, amended, betrayed, patched, and passed down. All resting on one assumption nobody has tested, that each generation successfully teaches the next one everything it knows. Because 10,000 years ago, a group of human beings got cut off on an island. They had every skill their ancestors carried, and over the centuries that followed they forgot how to fish. An entire people forgot how to fish, and nobody noticed it happening. Around 10,000 years ago, the sea rose and cut Tasmania off from mainland Australia. The people living there were suddenly alone, a population of a few thousand, on a large island, with no contact with anyone else on Earth for the next 400 generations. They arrived carrying the full toolkit of their ancestors: bone tools, warm clothing sewn for a cold climate, fishing gear, hafted stone blades, the accumulated inventions of tens of thousands of years. Dig through the archaeology, and you can watch it drain away. The bone tools stop appearing in the record. The fishing stops and scalefish vanish from their diet entirely, on an island surrounded by ocean. The sewn cold weather clothing goes in a place where it snows. Tools that had been fitted to handles turn back into simple stone held in the hand. When Europeans finally arrived, they recorded a toolkit of around 24 items. On the mainland, connected to a continent, people were using hundreds. Same species, same intelligence, same ancestors. The only difference was the size of the group and the water around it. Here is the mechanism, and it should worry you more than any radiation figure in this story. Knowledge is copied badly. Every time a skill passes from a master to a student, the student loses something. A trick that never got explained. A judgment in the fingers that nobody put into words. In a big population, that leak does not matter, because there are hundreds of practitioners and thousands of learners, and somebody, somewhere, copies it perfectly or improves on it. The best version survives and spreads. Shrink the population and the maths inverts. Now there are 3 people who know how to make the tool. 2 die. The one who is left was the second best of the 3. His student is worse than he is. Her student is worse again. The skill slides downhill, generation after generation, until one day the last person who could do it is gone and nobody notices because nobody left knows what they lost. Complex knowledge needs a crowd to hold it up. The Tasmanians had 4,000 people, and they lost fishing. The ship has 1,000, and it needs fusion. We have already watched this happen to ourselves at high speed. The Saturn V put people on the moon, and it was retired, and the drawing sat in archives. When engineers later wanted to understand its main engine properly, blueprints turned out to be nowhere near enough. They had to take museum pieces apart and scan them, because the real knowledge had lived in the hands and habits of technicians who had retired or died, and nobody had written down what they knew because nobody knew that they knew it. 50 years. One planet. Millions of engineers still working. Now hand a fusion reactor to 1,000 people, seal them in, and come back in 400 years. The frightening version of that ship's failure is a Tuesday in the year 2300, when a woman looks at a broken component and at the manual her ancestors left and understands every word of it and cannot do it. The instructions survive, the ability does not. And by then, the people reading those instructions may be different from us in ways they cannot see. 400 years is far too short to make a new species, and that is exactly the problem. The romantic version of this story has the crew stepping off the ship as something else. Taller, stranger, alien. Evolution working in the dark for centuries and producing a new kind of human. Evolution is slower than that, and the truth is harsher. 10 generations is nothing. Look at people from 400 years ago. Same species, same bodies, same brains, same jealousy and boredom and grief. Even the longer plans, the slow ships that take 6,000 years to crawl to Proxima at a fraction of the speed, only buy about 250 generations. 6,000 years ago, people were building the first cities. Bring one of them here, and they would be a person. So the crew arrives human, fully, exhaustingly human, with all the politics and appetite and stubbornness that comes with it, for 400 years in a tube. But 3 things do move fast, and all 3 are working on that ship from day one. The first is drift. In a small population, genes vanish for no reason at all. A version of a gene disappears because the 2 people carrying it happen to have sons, or happen to be on the wrong deck when a fire started. Multiply that across 10 generations and hundreds of variations simply drop off the list. The crew that lands carries a narrower slice of humanity than the crew that left, and nobody chose which slices were cut. The second is relaxed selection. For 100,000 years, our bodies were sharpened by things that killed us. Cold, infection, famine, predators. Every gene that helped spread. On that ship, most of those pressures are switched off. The diseases died out in chapter after chapter. The cold does not exist. Food is scheduled. Take the pressure off and mutations that would have been weeded out simply stay. The body stops being edited, which is where the island rule comes back to bite. Every isolated population on Earth drifts toward its island, because nothing is pushing back. Birds on islands with no predators lose flight, because flight is expensive and nothing is chasing them. The animals do not decide to give up their wings. The wings just stop being paid for. The ship is an island with no predators, no seasons, and no distance. The third is development, and it is the fastest of all because it needs no genes and no generations. A body built at a fraction of Earth's weight, under lamps with no horizon, in scrubbed air, comes out shaped by that world within a single lifetime. The child born in year 100 inherits our DNA and grows into a body that Earth would break. So put it together, and the honest picture is stranger than a new species. They arrive human, recognizably, genetically, one of us, and their bodies belong to the corridor. Their immune systems belong to the corridor. Their sky, their gods, their language, their weight, their eyes, all of it tuned to a metal cylinder 4 miles wide. They will be humans who are perfectly, exquisitely unsuited to a planet, which raises the possibility their ancestors never considered. And then a message arrives from Earth, and it makes the whole voyage pointless. In the year 2600, a ship built after theirs sails past them at 3 times their speed. The crew watches it go. 200 years of their families' lives, every birth permit, every funeral, every generation that maintained the reactor and taught the next one how. And the whole point of it just overtook them, waved, and vanished ahead. That is the incentive trap, and a researcher put a name and a formula to it 2 decades ago. He called it the weight calculation. The logic is simple enough to hurt. Suppose humanity's best achievable travel speed keeps improving. Slowly, unevenly, but it improves, the way it has for every technology we have ever built. Now, you're standing on a launch pad in the year 2200 with a ship that does 1/10 of light speed, and you have a choice. Go now and arrive in 400 years, or wait a century, launch a better ship and arrive sooner in total, counting the weight. Run those 2 lines against each other and they cross. Below a certain rate of progress, waiting is foolish, because the improvement will never catch up. Above it, leaving now is worse than useless. because a ship launched after you passes you in the dark. And in between sits a departure date that beats every other departure date, which means every ship that leaves before it wasted itself. Post a letter, then somebody invents email. The letter still arrives. It just arrives into a world that stopped needing letters. The same review that priced out these ships said it plainly. The resources involved push a world ship beyond any sane economy until somewhere past the year 2300, and by then a cheaper, faster way to travel may have arrived and made the whole idea a museum piece, an arc obsolete before it was finished. Now picture the moment on board, because this is where it stops being arithmetic. The message reaches them in the 8th generation. Earth got faster. Earth already sent people. Earth landed 60 years ago, and the colony is thriving, and they are radioing ahead as a courtesy to let the old ship know that a welcome is being prepared. Every person alive on that vessel was born to a mission that no longer exists. The voyage kept going. The reason for it did not. Their ancestors gave up a planet for this. Their parents gave up children they were never permitted to have. And the destination they have been aiming at for 8 generations now has cities on it, built by people who left Earth centuries after their family did and got there first. Then it gets worse, because they still have to land. They arrive as immigrants, physically wrong for the gravity, since they were built for the ring. Immune systems that have never fought anything, walking into a settled biosphere, speaking a language that has drifted for 400 years, carrying technology that is a historical curiosity, with skills that the colony below outgrew a century ago. Their great achievement, the thing they were bred and scheduled and governed for, is a slow boat, a footnote, the long way round. So somebody on that bridge is going to ask the obvious question, and it will be the last decision in this entire story. Why land at all? They arrive at the promised world, they look at it through the window, and they decide to keep flying. Start with what is actually waiting at Proxima. The planet sits so close to its star that a year there lasts 11 days. That closeness locks it in place. So one face stares at the star forever, while the other faces the dark forever, and the planet has stopped turning relative to its sun. A world that does not turn cannot generate a magnetic field, which means it has no shield. And it needs one, because that star has a temper. In March of 2017, Proxima Centauri brightened by a factor of 1,000 in 10 seconds. A flare that size would hit that planet with thousands of times the radiation Earth ever takes from our own sun, and the flares keep coming. Repeated blasts like that strip the ozone out of an Earth-like atmosphere by 90% within 5 years, faster than any planet could rebuild it. The ultraviolet light reaching the ground during one of those events arrives at roughly 100 times, the dose that kills the toughest microbe we know of. 400 years, 10 generations, a birth schedule, a rewritten constitution, a tank of frozen strangers, for a burnt rock in a strobe light. So the 8th generation gathers at the window and looks at the destination their ancestors chose from a spectrograph reading 4 light years away, and they see what a spectrograph could never show them. Then they look around at their own world, the rings turning, the farms lit, the temples, the schools, the graves of 200 years of their family, air they can breathe, weight their bodies were built for, every person they have ever loved. Down there is a planet that would break their legs, poison their lungs, blister their skin, and murder their immune systems inside a week. The ship is home. The planet is the alien place. And so the answer to the question at the top of this story turns out to be a trick. How long could humans survive inside a generation ship? Line up the evidence. 6 months in a Siberian box with meat carried in, 2 years under Arizona glass with oxygen pumped from outside, and everyone 16% lighter. 25 years in orbit, resupplied by a rocket every few weeks, with a crack the best engineers alive cannot seal. That is the record. That is everything our species has ever proved. So the honest answer, using what exists today, is months, maybe 2 years. The ecology goes first because it always has, then the hardware, then the knowledge fades out of people's hands, then the genes narrow. Nobody makes it out of the first century, and here is the part that should stay with you. Every single item on that list is allowed by physics. Every wall in this story is a wall we built, from ignorance, from never having tried. The loop was always the hard part. The distance was the easy half. which means the first True Generation ship will be finished long before it launches. It will be finished the day some sealed world on Earth runs for 100 years without a single delivery, and the people inside walk out healthy. Until then, everything else is a drawing. The stars are waiting for us to learn how to keep a garden alive.